Yeah, it's the first time I've tried to present from WebEx from the Mac, and it needed to give it permission to record my screen, I guess. So anyway, yeah, so I'm going to talk to you guys about our Upstream First efforts for our kernel driver, and just kind of in general stand on a soapbox about Upstream First development and how important it is, and how it can actually be a benefit to to the business, and especially in the realm of stuff that we're in here. There we go. All right. So I think by now everybody should kind of know what Cornelis Networks is. We've talked at this workshop, I think, for 3 years or so now. We're the Omni-Path group that spun out of Intel. Our product, OPA Omni-Path, that's the low latency, high speed fabric interconnect, 100 gigabits. We are coming out with 400 and beyond. And I'm I kind of lead the kernel development, and one of the original people that wrote the driver that I'm going to talk a little bit more about. I'm not, however, going to talk about licensing. I'm not a lawyer, and every company and person has their own views on what things should be. I'm not going to talk a whole lot about the architecture for the HFI 1, but I do have some history about how it made it into the kernel. And for those that remember, it was a rocky road. Doug will surely remember. But the thing to keep in mind here is this isn't strictly related to Cornelis Networks or HFI 1. It's the concepts I'm talking about apply to other things as well, can apply to any software project, whether it's the kernel or libfabric or whatever. It's not so much a guide on how to upstream drivers, but rather, like I said, kind of me standing on my soapbox, telling people to, this needs to be a priority. I don't think we need to talk a lot about why Linux. I think everybody here pretty much is sold on that these days, and why open source. I don't think that should be a hard sell to this group. It's certainly beneficial because you've got extra people looking at the code. In the case of the kernel, you've got thousands of people looking at the code. There's a sense of community where competitors who are actually working together. And for us in particular, this is the way to make your code get into the distro. Customers want to just be given a Linux distribution. They want to just be able to run it. They don't want to have to install 10 different things after they get it just to get their network off the ground. It's just easier that way, and it's what they want. And this is how you become ubiquitous eventually. So companies, particularly marketing types and less technical people that don't grasp the concepts, they see some drawbacks with open source. For one, the code isn't yours anymore. So with the kernel, when we submit our driver to the kernel.org, it's not ours anymore. It's not owned by us. It's owned by the world. Anybody can put code in it. I mean, we do have some say, obviously, and this is where working together with with the community and the people that are your competitors and stuff comes in. But you can't just throw whatever crap in there you want. And I'll talk about some examples later. There's a notion of the timeline. It's not so much that it's drawn out, it's that it's not in your control, and talk more about that too. So for us and in general, you need to pick your community. And so why did we pick kernel.org? I mean, obviously it's because that's the path to get into the distros. It's the huge community. But companies, they need a way to get hot fixes to customers. You need a way to deploy things that aren't necessarily meant for kernel.org. So debugging code or something, if you've got a problem on a customer system, how do you get it to them, when it's not meant to go to the world. So you still need to be able to do these. So how do you meet all these requirements and still, you know, and still accomplish your goals here? So the principle that we follow is upstream first. Like I said, upstream for us is the kernel.org, can apply to anything. It's important to realize it's not upstream only, it's upstream first. So while it would be nice if all you had to do was put your stuff upstream, it's in kernel.org, and that's all you had to do. That's not the case. It's upstream first, not upstream only. Now, it's as your product becomes mature and there's less and less churn, it kind of becomes more and more towards upstream only, because you're putting in the changes that, you know, and it's not on this fast basis, and eventually things filter into, you know, into the distros because things are stable. So consequences of not doing upstream first, and this is, in my opinion, is the worst thing that you can do to a customer, is, you know, you've got this code, you put it out there, and oh crap, somebody finds a major problem with it, or, you know, something, and you have to take that feature away from the customer. And there's pretty much nothing else you can do that's worse than that. So it's not foolproof though. I mean, obviously, you know, problems can be found at any time, but, you know, the goal here is leveraging that community to find those problems early. So it's not just your team that's looking at it, it's the whole community. So I've talked about open source and why it's good and bad, and the upstream first, and what happens if we don't do it. There's really two ways to release software. So that's what I'm going to transition to here. One is this black box approach, where, you know, you send some code out to the community, and it goes to the upstream. But you also release this code to customers. You know, you release a package for them to install, and nobody really knows what's in it because it's not, you know, it's not necessarily open. It might have latest fixes, it might not. There's no way to tell. This is the benefit is you get to release whatever you want, good or bad. But in the end, it's not friendly to users or the community, and, you know, this is not bettering technology at all. So the better way is obviously, you know, be open with it. You know, this is, like I said, code goes to kernel.org first. But then, you know, for us, we have to, we want to be able to support Linux, the different Linux distros. So we put that code into GitHub, or, you know, this could be anything. It's still an open source community, it's smaller, but, you know, it's still important. People still see everything that we do, but it's, and it kind of is its own upstream. The point is, though, that the stuff that is going into here has already been here. So I guess you really could move this arrow over to here. So the code that goes here is, you know, upstream first, but not upstream only. So if there is a, you know, a hot fix or a security issue, something else, there is still that path to get it here. And this code can also go, you know, you could still package it up and ship it to customers, just like, you know, like you had before. So, you know, I've blown through all this stuff real quick, but there's a big question that comes up, and is, you know, like this is a great and all, but is this code the same? And turns out, no, this code is not the same, because the code, you know, in our case, is we're putting this code out there to run on the distros. So that it's not, there's, when you actually look at it, this code blob here is all the stuff from the kernel.org, plus stuff to make it work on all the different distros, because each different distro has different ways of, you know, doing things in the kernel. They have their own different backports and things that have been done to it. So the problem is that as time goes on, this gets more and more different. And the backport work becomes harder and harder and harder. But like I said, so the goal is to work with the distros, but there's got to be a better way of doing this. Although this is what we did at Intel when the project was called IFS, and what we did early at Cornelis with our OPXS. And it does the job. It's like I said, it's tried and true. It's what we've done. It accomplishes all the goals and it gets customers running on the distro they want. But there's something better to do than that. So this is just kind of another picture showing, the problem that we ran into with the way we were doing things with the single monolithic, code base. And you've got, kernel.org, it moves along. So does, the different distros, and then they have, their own special sauce or their own, whatever to, backport things. And as we're sucking all this stuff into our IFS, it becomes this giant amalgamation of all of this. So the problem with this is not only, like I said, is it the work to be able to backport stuff gets harder and harder, but more code is more risk. I mean, the more complicated you make things, the more likely you are to break things. And not to make light of, but we're duplicating the work that the distros are already experts at. I mean, this is what they do, is backporting things, and we're just doing the same thing. So, how do we do better? We let them do what they do. We, instead of having one code line that has everything in it, we have, a branch for each distro that we support. So we, our stuff still goes out to kernel.org, and the distros handle the backporting it. It goes into their releases, and we pull this into our stuff, and then we can add our things on top of it. So we can add that value add or those hot fixes or whatever needs to be done. So we cut down on the backport tremendously, and now customers get a driver that is literally what the distro ships plus something else if you need it. And now, instead of that, that picture where you have all the code coming from all these different places, we've literally got just the kernel.org stuff plus the distro stuff plus some tiny little bit of, something that we had to add. So what does it take to do this? Well, first and foremost, your company has to, fully embrace upstream first development. And, Cornelis, one of the best things, that I've found in, the time that I've been there is it's not just lip service. This is something that we really do believe in and follow. And it's, the kind of thing that I've been screaming about for years. And, we just kind of get it now here at Cornelis. So it doesn't just take that. I mean, belief is one thing, but you have to put in the effort. You have to be able to validate your upstream kernel. You have to be able to have, continuously know whether the stuff that's going in upstream is okay or not, because it's going to land in the distros eventually. And this is where, the FSDP and, stuff that we're doing there could be very attractive, because it can just be, running nonstop for you. Now, obviously you have to do more validation, but, the more the better. Another important thing, and maybe this should have actually not been a sub bullet, but upstreaming your code cannot just be a side task. It is the task. It's not just something that all right, the code's checked in internally, we're done, we move on, and maybe somebody will push it out upstream later. That doesn't work. You also have to test this stuff with the Linux distros. You have to test it early. I mean, ideally, it helps to partner with the distros, and so that your code can be tested, and we're able to make sure that our drivers are fully vetted and work with the distro by the time it GAs. There doesn't have to be this long lag between when they get things and when you can actually release. But there's always a but, and we're in the business of making new stuff, and that new stuff is often quite secretive between companies. So it's harder when it comes to the new stuff. But this is where having the whole company buying into everything, it is crucial, because you have to upstream what you can when you can, and everybody has to be bought into it, not just the guys that are writing the code. So with with kernel.org, you have to have this let's say a good foundation in kernel development upstream process. I mean, you have to have people that know how to upstream stuff. You can't just, it's not, I mean, the job used to be go find engineers that can build stuff, that can, take this hardware and make it work. But it's not only that. We have to find the engineers that can do that, but also people that know how to get it upstream. So days of the upstream development stuff is just being a side task or whatever. That's over. You either collaborate and work in the community, and good things will come, or you wall yourself off, and you will start to wither. A lot of people think the kernel moves slow. Well, if you think about it, the kernel doesn't move slow. How many software projects out there can punch out a new release every 8 to 10 weeks? It's like clockwork. Not very many. Linux does this. Yes, it's fair point that the distros do increase the lag somewhat. That's why having that path that I showed before to get those hot fixes and stuff out, that's why that's important. Working with distros is also, having a good relationship with them also helps. Distros, Red Hat has their Z streams, Celeste has their security updates. There are updates to their kernels. Working with them for big issues, you may just drive that through there to get the code there to get the code in. But as long as you keep pumping the code out upstream, the distros are going to pick it up, and it's going to get in eventually. So even if you have to push out a hot fix for now, once it's been accepted upstream, as in the community says yes, this is good, then you can feel free to push it out to your private thing, because it's already been blessed in a sense. It's not something that you have to worry about removing from a customer at some point. So I've kind of stood on my soapbox here and talked about why Upstream First is great, and how to do it and everything. And so I'm going to kind of leave you guys with the story of how we got our HFI1 driver upstream. And I say this wholeheartedly: do not do what we did. It's not a story to be repeated. So the HFI1 driver, it's been through a lot of changes compared to what we first put out there. It was initially a straight up copy of the QIB driver, which made sense to do, because it was the hardware was fairly similar in terms of the major components and how it's structured. So it was a good framework for a driver. So it's logical to use that code, which that's not the issue. The problem was the verbs code. So the way our technology works is the verbs is done in software. So the verbs code between QIB, the former InfiniBand driver, and HFI1 was basically identical. And turned out there was also this even older driver called the iPath driver, which was some hyper transport based card from, I don't know, eons and eons ago. But anyway, so there was 3 copies of the verbs code then. So if you had a bug in one, chances are you're fixing the bug in 3 different places. And the upstream community really, really did not like that. There was a lot of, if you go back and look at the mailing list from back then, or if you recall, there was a lot of nasty emails exchanged from certain competitive companies, we'll say. That's definitely not the case today. It's a very different landscape. The guys that are actually the maintainers are, from a competitor, and we have a very good, working relationship with them. And, things are just, better in every sense of the word. But, before we got to there, it wasn't just the verbs code. There was a bunch of other stuff wrong with the driver. I mean, the verbs was the hardest to deal with. And we ended up actually having a whole other driver to deal with the fact that we had the verbs code duplication. That's the rdmavt driver. And that was like 7 months of my life. But there were other things with it. So we had this Twizy stuff, which is basically I squared Z. And we implemented our own thing. We didn't use what the kernel had. We had multiple character devices, snoop capture. We had this register debug stuff. There was a number of things, but point is, we had a list, and it was literally a list that got checked in with the code when we went into staging. So there's a part of the kernel, which is the staging area, which is for drivers and stuff that aren't ready to go into the main line. And there's a lot of problems that come along with that. And not to mention that it's like free reign for lots of people that want to get kernel patches in and get their name in the git log just by changing something minor, like fixing a spelling mistake or something. But they do that, they blow up the size of a string, and now they've overflowed something. And so there's a lot of things that you have to defend against, patches coming in from, and a lot of them are well-intentioned, but some of them are people that, I call them patch trolls that just want to churn patches out. And if you look at the Linux RDMA mailing list the last couple of days, you'll see a perfect example of one of those guys. So when I say it's a story not to be repeated, it's the whole not having upstreamed anything before. So that's why all this stuff was there. Why do we have the verbs code? Why do we have all these other things that were there? Our view was, this is our driver. Why does anybody care? Who cares if we have multiple character devices? Who cares if we reinvent the wheel with this the 2-wire serial thing? It's all in our driver. It doesn't affect anybody. But in reality, it does. Perfect case in point is the character dev stuff. There was actually a CVE related to character devices in Linux a couple of years ago. Forget how many years, but actually we met at, it was disclosed to us at the OFA conference years ago. All of the kernel people, we actually met in a room and talked about it, and it's when we found out. And there was a whole when you have a CVE, there's a whole process that goes into dealing with it. And the fact that we had a CDEV meant we were exposed to it. If we would have had multiple, we would have been even more exposed. So they're even though it is something that's just in your driver, it's not always it's not a don't care. So that's the benefit that you get from working with the open source, with the upstream community. So okay, so why did we have all this stuff like that? We had brilliant engineers, our guys, we had a pretty big team writing the driver, and they know their stuff, they know how to program in a kernel environment. That's not it at all. You know, writing the code and making it work is one thing, and making it upstreamable is totally another. So we didn't have that. So the QIB driver that got into the kernel long time ago. It was basically grandfathered into the kernel, and it was just there. So it had a lot of problems that never had to be addressed. So, you know, the big lesson here is for companies to, you know, pay attention. You need to have people that have experience dealing with their community. And unfortunately, like anything else, the only way to do it is to, you know, to do the work, and you know, you pay your dues. So you need to, as a company, you need to buy into this whole putting things upstream first and working with that upstream community. Bottom line is, you know, bold, underline, you know, needs to be a priority, and you know, often it's not. So so back to how is this related to upstream first stuff. So all that stuff that we had to cut out, you know, we want to keep because customers had already, you know, been exposed to that. So now we have, you know, we have distro drivers, but we're in staging. So, you know, we're limited to tech preview. So supported by the distros, or we're in the distros, but not quite where we want to be. We have the upstream, we have IFS. So we've got all these different code bases, and we're in that exact problem that I was talking about earlier. You know, as code diverges, upstream fixes become harder and harder. When, you know, new APIs are added, it gets even worse. And there's, you know, prime example is there was some work done recently over the last, you know, couple of years to start taking some of the verbs objects and moving them, moving the allocation and management of their lifecycle out of the drivers and moving it into the InfiniBand core, which makes sense. And in the upstream kernel, it's not a huge thing to do. But when you're you know, when you have to backport to, you know, one kernel version for Red Hat that does not have it, but SLES does, now you've got a real mess on your hands. And that's just, you know, goes into all that stuff. And that picture that I showed before where you've got all the different boxes. So how did we get past all this stuff with HFI1? So, you know, and it's exactly what I'm talking about here. We started doing upstream first. We stopped putting stuff into our release and shipping it out and letting customers have it before it's been upstream. So it's actually, there was you know, one of these come to Jesus or your deity of choice moments. We, I said, long time ago in a conference room far, far away. It's, you know, we being me and the other kernel developers, we met with the upper management, you know, of the program at Intel at the time, and spent a whole day in a conference room explaining how all of this stuff could have been avoided, and we could have been to market faster and had, you know, better quality. All we had to do was upstream first. And there was a lot of kicking and screaming even after the meeting, and with people that had not bought into it. But eventually, you know, everybody did get on board, and everything was going in the right direction. And that's how we got over all of this stuff. So before I, you know, run out of time here, I'll just mention, you know, like I said, open source is key. Upstream first is the way. But, you know, nothing is absolute, of course. There are going to be times where you can't upstream it. You just have to go with it, you know, into your product or whatever. Security things, or, you know, but that's not the normal. That's what you want to avoid. So I say that it's a goal. Nothing is absolute. At Cornelis Networks, you know, we fully embrace this whole upstream first as a key part of our approach to openness. And that's one of our definite value adds that we have, is how open everything is. And the HFI1 driver is an actual real world example of upstream first development these days. So other efforts, I say following suit, OPX, that's our provider in the fabric, and I believe Tim is going to talk about that in the next talk. So that's what I have for you guys here.
Cool, thank you. I enjoyed that. I also like the go-to reference there on your last slide. That was fun. Okay, so I figure this is either going to be something that everyone pretty much agrees with and is bought onto, or we'll have a lively debate. So, do we have any comments?
I have a couple comments actually. And what I wanted to say is just to add a little bit of more backing behind what Dennis is talking about. I don't know how many of you might remember the history, but there was a long period of time ago when Red Hat used to ship the OFID distribution. And there came a day when we stopped shipping the OFID distribution. And the entire reason behind that was the fact that OFID decided to do a non-upstream first development model, and specifically implemented a software feature that I'm not going to name. And by implementing that feature in their own software before it went upstream, what ended up happening is anybody that wrote software to use that feature against OFID, once the feature landed upstream, it ended up having a completely different programming API. So they had to rewrite everything that they did. And this is the kind of thing that Red Hat as a company understands. As a distribution, we understand that we cannot cause that kind of pain for our customers. It's simply a cardinal sin. And so we don't take, and Denny did mention that the new stuff is sometimes, the stuff you kind of have to keep secret, but the new stuff, I would argue, is absolutely the most essential to do upstream first for exactly this reason. It was not doing upstream first on a new feature that caused Red Hat to break from OPID distribution and start shipping pure upstream. And we've never looked back since then. So I just wanted to add that historical point behind what Denny had to say.
Cool, thank you. We also have a comment and a question from Sean. For libfabric, OPX takes the approach that is more along the lines of pushing a large number of patches in bulk. Are there any plans to change that model?
Well, that's probably more of a question for Tim.
Yeah, or maybe I can interject.
Yeah.
Yeah, I mean, we're certainly going to move towards pushing commits more frequently than we presently do, which at present we're sort of guided by the libfabric release cycle to upstream. We want to do it more frequently than that, but because of our validation process, it's never going to be as frequently as most, at least not in the near term. So, we'd like to push monthly. That's what we'd like to get to, but it's not going to be, every commit, just to be clear, individually.
Very cool, thank you. Any other comments?
My turn or someone else?
No, John, cheers.
No, so